Hello everyone, warm welcome from Kuala Lumpur to the ABU WorldDAB three-part webinar series on DAB Plus digital radio technology implementation and rollout. The series focuses on the current status of DAB Plus digital radio technology, business case, DAB receivers, head-end systems, transmission systems, RF network design, and sharing of some experiences of DAB Plus trial implementation. Before we begin, just a quick note on using the webinar control panel to send in your question. As you can see on the slide, please type your question in Q&A tab and keep sending them to us as and when you have. We'll take the questions at the end during the Q&A session. Finally, for your information, we'll be sharing the presentation slides after the webinar series by email. As you know, today is the second day in this series. As in the previous session yesterday, we have multi-speaker presentations today, and the topics are mostly on DAB receivers and head-end systems. For further program highlights and moderation of the day's session, I would like to request Dr. Les Sabel to take the control for next 90 minutes. Over to you, Les, please.
Thank you very much, Shrek. It's a pleasure to be with you again today. We have quite a distinguished panel today of speakers covering a number of topics. We have Catherine Zabel-Brown, who's going to talk about getting DAB into the market, with Albert Zhang, CEO of Keystone Semiconductors, talking about receivers, particularly home receivers. And hopefully, Albert, you've got some interesting new products you can share with us. We have a video presentation on the connected car from Roger Langto, who's the Director of Automotive Connected Mobility at Strategy Analytics. We have Lars Peter Lundgren, who's the Marketing Director of Panida, who will give us a presentation on the head-end systems and where they're going in the future. And we have Arasri Srirasa, who's the Director of Satellite and Orbit Management Bureau at the MBTC in Thailand, and formerly Director of Digital Broadcasting, and who was a major contributor to getting the Bangkok trial for DAB Plus working. So we have a very interesting presentation from Arasri. So with that, I think I'd like to ask Catherine, if you can please start your presentation and tell us how to get DAB into the market, please.
Thanks, Les. So I know a lot of you on the webinar today, and lovely to see you again and speak to you all again. For those that don't know me, I'm Catherine. I project managed a lot of the aspects that we'll be talking about today in terms of establishing the DAB market here in Australia. And every country is different, but there are some common stakeholders that we need to engage with: the broadcasters, the regulators and licensing bodies, the automotive industry, and of course the receiver manufacturers and retailers. So let's start with the broadcasters. Often it's the technical people that start to talk about DAB and get interested and excited about the potential that DAB delivers for the business. But they're doing that while all the other parts of the business, the sales, the management, the program makers, are focused on websites and apps and their social applications, their AM to FM business, podcasts, events, and so on. So things won't move forward for you as technical people and for the business unless we can get all those people on board. And the way to do that is to explain that DAB is a cost-effective, reliable new platform. It sits alongside all the other existing digital activities and events that people are already engaged with, and you can repurpose a lot of the material and the work that is already going on in the business on those apps and social sites. And as Adam Williscroft spoke about yesterday, this helps broadcasters maintain audience share. It attracts these niche audiences that you haven't been able to get on your analog channels with new content, new ways to engage with them, however and wherever it suits them. It also provides the business with new revenue streams if you're a commercial or private broadcaster. And combined, these platforms create a really successful, thriving environment for the radio industry. And let's not forget that the competition is no longer the other broadcasters in the market for share of ear. It's these other big digital devices, these IP or Bluetooth connected devices, the ones with voice command or Spotify Connect. They're increasingly challenging us for share of ear. However, they have had some issues in the home with privacy. And one traditional broadcast receiver manufacturer has actually brought out smart speakers, but you can listen to the DAB without having the IP connectivity engaged so that you can ensure your privacy, or you can pop it up if you like a song on the radio and discover it and put it into your own playlist. So it's the audience having the control. So next step is obviously to get the regulatory and licensing framework right. And often we hear that things aren't moving forward in our country because we're waiting on the regulator to tell us what to do. So what I would suggest, working through all this experience, is that broadcasters get together and they talk about what they want to see for a incentive to move to digital, to invest and to take the time and then produce the new content. So if the broadcasters can agree on who should be entitled to move to DAB, who are the biggest broadcasters that will be able to influence audiences and take them across while simulcasting their existing program and creating new compelling content, those are the broadcasters that should get together and start to drive the agenda. And let's not forget that even if you're not planning to go DAB anytime soon, the telcos are very keen on the bands that DAB operates in, the VHF band 3. They will squeeze TV down and TV will squeeze broadcast radio down into those bands. So even if you're not planning to move forward next year, it's absolutely essential to move forward with that spectrum part and talking to the licensing policy people. WorldDAB has loads of different examples from different countries about how that licensing policy can work. So it's really good to get in touch with them and discuss what it is you'd like to see in your markets. Next, of course, is the automotive industry, and they are absolutely key to our future. Fortunately, now there are so many brands that have DAB as standard. In their vehicles, it's factory fitted, it's performs really well. So you may already have DAB in your cars that are coming into the market now. And we talked to all of these brands when we started, did workshops for them, explained what DAB was, who was going to be on DAB, what sort of content we were going to be able to access on DAB, what sort of functionality it provided, what frequency bands we were using. We even took them out in stretch limos and drove them around and showed them how the signal performed compared to AM and FM. So you can really engage with these automotive sector. And it's really important to do that because this is the dash of, not too far in the distance, this is the dash of the future. It's really a very much more compelling offer for the audience, and the car manufacturers are looking to broadcasters to make radio look better in that dashboard. AM and FM won't cut it, and so it's really important that you start to think about this connected vehicle, the fact that broadcasters really need to explain to the car industry that radio is more resilient than IP only. We know that from the bushfires that happened in Australia recently last summer, when everybody was trying to listen on their phones. The congested cells meant that people were only able to listen to emergency advice via their radio in their car. So the broadcast platform was the last one standing when the IP and other devices were falling apart, or the power was off and they couldn't recharge batteries and so on. So, but we can actually make radio look better in the dash. Absolutely we can. We just need to ensure that more metadata is provided in terms of images and texts over the DAB+ platform. And then we can actually add links on URLs to the DAB signal so that listeners can engage with our content live. So we have all this content. We just need to build the DAB platform so that we can actually use it in these smart devices. And so it's not just the content from your analog radio that you can be using over these devices. It's all the time-shifted programming, like the streamed radio. People could be pulling in podcasts and so on. Listeners want to be able to get what they want from radio now, and it doesn't have to just be linear radio. So they can use DAB or they can use apps, and they can re-engage with us. They can listen, they can tweet, they can vote on the song. They could even buy or share digital content with their colleagues and friends. And finally, the receiver manufacturers and retailers. And I know that we have Albert from Keystone speaking next, so I will just talk mostly about the retailers. Thinking about the retailers in your market, and again, Asia is very different, Asia Pac, to the other areas, particularly in Australia, where we have big department store chains. We also have specialist retailers, home audio suppliers, and aftermarket installers for the car aftermarket systems. We have several big discount department stores that are chains, and you go and talk to the head office, and in UK has Halfords, similar sort of thing. And then of course we have an increasing presence for online retailers. And just watch those retailers. Very often they'll sell low-cost receivers, and broadcasters can't really control the quality of those receivers. So it is important just to really try to engage with all those aspects and explain why it's important to get good receivers into the market. WorldDAB has all of these as members, so you can use WorldDAB's resources to get to these people. Explain to them that you might need Thai characters, or you might need Arabic characters, or other things that are specific to your region. And encourage the manufacturers to support these advanced features. They're quite affordable now, and they certainly make radio look better. And make sure that metadata is up to date. There's nothing worse than getting into a car and having a look at something where the channel has changed and it looks terrible, and it's actually being called the wrong thing, for example. So make sure your systems are in place, that the metadata is correct and accurate. And as we move forward, the chances of us getting DAB into handsets is increasing as we go forward into the Asia Pac, these tech-savvy markets. So we're really excited to see such big interest in this webinar series from all around the world, in fact. And finally, never stop building the awareness in your market. The importance cannot be overstressed of marketing, awareness building, marketing, telling people all about what is available on DAB+. And WorldDAB again has some excellent examples from around the world of how to do that. So I've had my allocated time. Thank you very much. If you need any further assistance, those are our contact details. Thank you.
Thank you very much, Kath. It's very informative. I particularly like your comment about the metadata and how important it's becoming, and how important it is to maintain its currency. We'll hear more about that, I'm sure, in the next couple of sessions. But for now, I'd like to introduce Albert Zheng he's the CEO of Keystone Semiconductors, and Albert's going to give us a presentation on the latest in home DAB receivers. So over to you, please, Albert. Thank you very much.
Ladies and gentlemen, the topic I want to give you today is DAB receivers for home. This is just the lesser mile of the roadmap that is shown by the previous speaker. My name is Albert Zheng. I'm the CEO of Semiconductor Corporation. I'm from Taiwan. To make you see better my presentation, so now I will turn off my webcam. Okay. Establishing DAB market is just like build a building. The building of DAB is on 3 pillars: transmitter, receiver, and the content. The content is basically built on the culture of a country, and the receivers has highly to do with the industrial production of a country. So I will discuss with you about the importance of receivers for building up the DAB industry. Because it should be owned by many people. Therefore, affordability is very important, and variety is also important. You should have a lot of choice to make, and because it is used by many people, therefore user friendly is also very important, and it should be satisfied by many people in every corner of the country. Therefore, high quality is very important. And but not the least, it should be able to be manufactured easily. So highly integrated key components and the modularized modules is very important. I will give you a brief understanding of receivers. I will tell you about the receiving types, receiving capabilities, receiver. I will give you some example and pricing, and especially I will talk about the local characteristic support. First, the first receiver types I will present to you is the kitchen radio. Kitchen radio, the key feature of kitchen radio, as the name implies, kitchen radio is used by housewives to accompany them doing their housework. Therefore, portable is very, very important. And it should have a good speaker so that it can be listened very clearly everywhere. And it should have high sensitivity. So even if in a corner of the kitchen, it can still pick up the signal very clearly. And it should be very easy to operate, like a tuning, volume up, volume down, and to find out your favorite quickly. Here, the picture gives you some examples. This picture also shows some examples. You can see a variety of kitchen radios. This one, I will give you a special recommendation because it is attached to the cabinet of your kitchen. Therefore, it is a real kitchen radio, so that you don't have to find a place to put it. These pictures are also various kind of kitchen radios. Another receiver type is called the living radio. As the name implies, it is used in living room. The key feature is that it should be stylish because it is in living room. Therefore, sometimes it is served as a decoration in the living room. And it should have excellent speakers so that people can enjoy the sound in the kitchen, in the living room. And the sound, it should have high fidelity and high sensitivity. Again, because it is used in living room, it is quite complicated. It may have a CD, Wi-Fi, and even remote control. I will give you some examples in these pictures. They are all products given by Pioneer. And I will use my laser pen. Yeah, this one is from Geneva Lab, and all others from Sonoro. You can see the radios is very fantastic. Okay, this is other examples of living radio, which you can see. They are from JVC and Neon. The next type of DAB receiver is called clock radio. As the name implies, it has a prominent clock. The key feature is that it should be compact, easy to carry, because it is sometimes used when you are traveling. So it can show the time prominently, and sometimes, usually it will have alarm. And the alarm is not the traditional beeper. In addition to the traditional beeper, you can use the DAB sound, the beautiful DAB sound as the alarm. And of course, it should have good speakers and good sensitivity. I will give you several examples of clock radios. They are very small, compact, and beautiful. Receiver capabilities, we classify as just the basic and the feature. The basic elements of a DAB receiver is you need DAB alpha tuner, a baseband decoder, and audio decoder. Actually, it is very complicated, but fortunately now we already have integrated solution. So they are all integrated in a single chip. And more than that, it is also integrated with other components like matching circuits into a module. Therefore, to make a receiver becomes an easy task. Besides these elements, you also need others. Let me introduce one by one using this picture. You need a keypad. Here you can see the keypads. The keys enables you to choose what you want quickly. And sometimes you use a knob or turning wheel, which can make your selection even more quicker. The display, sometimes simple LCM is used, but sometimes more complicated LCM is used to display the information more clearly. Of course, speaker is necessary, and that's it. But the name of the list is the antenna. Antenna is not shown here because it is hidden behind. Usually, telescope antenna is used. If you want to make your receiver more attractive, you can improve the color display. Here, I will give you another example. In this picture, you can see there is an icon there. It is the feature of DAB. It can have programs. It can have pictures together with the sound. Therefore, the picture can be seen clearly in color display. And then moreover, some people even use a more fantastic 4-inch TFT so that you can see this picture. It is very, very colorful. And another receiver is called hybrid receiver. What is hybrid radio? Hybrid radio, actually, it combines DAB plus FM internet radio in the same unit. Therefore, if any one of the content is not available in this area, then it can automatically switch to other media which you can continue listening to the service you want. They are usually implemented on IRDAB. In other words, it's internet radio plus DAB together. But to make it into a smartphone is a good choice. Fortunately, now we have LG. LG smartphone has a built-in DAB, but not every smartphone has such a feature. Therefore, we recommend a smartphone connected solution is a way to solve this problem. For example, this solution, we call it WorldDAB Go. It is connected with the smartphone using Wi-Fi. Therefore, there you can use the larger screen of the smartphone to see slideshow and the SPI. SPI is Service Program Information. As you can see here, there is a lot of program informations which can only be seen when you have a bigger screen. The larger screen can also enable you to show radio DNS. What is radio DNS? Radio DNS actually means the domain name system can be broadcasted along with your audio and your slideshow. Therefore, the receiver can use the URL, the web information to fetch the data that is presented in the domain name server. For example, the station identifier, in other words, your logo. This picture shows your logo clearly. Another advantage is that you can use it to show journal line. Journal line is a feature proposed by the Research Institute of Germany called Fraunhofer. Journal line is, as the name implies, it is a list of journal titles. So you can have a quick grasp of what is going on in the news. If you are interested in any one of them, you just click it. You will find more details of it. And if you need more information, they have the hyperlink on it. So you can click it and you can switch to the web to see more information. Another important thing is that, as the previous speaker said, we need local characters like Arab or Thai, etc. We already have a partner in Thailand, IFZ. They have already produced a receiver which has Thai characters. I think you will be interested in the price range. Also, I will give you a summary. The low price now is only about maybe 40,000 US dollars. Sometimes it can be even lower. The medium price, I will give you Senjin as an example, is 100 something. And the high price usually goes with living audio, 200 something. And there are some decorative receivers. The price is very high. For example, Sonoros. The price can go to even to 2,800 US dollars. I think you will be interested in how to make a good receiver. It once was a very difficult job, but now it is very simple. First, you choose a highly integrated module. And you don't have to start from scratch because they will provide you a lot of good reference designs. So use this reference designs to design your receiver. And you had better cooperate with a reliable partner because they can give you training to your engineers to let them know what DAB is. And when they do the design, the partner can help you review the circuit design and the layout. Layout is very important for DAB because it has RF signal. The layout has a very big influence on the quality. Also, they will help you test to assure the quality. The models that I mentioned before has one thing in common. They all have a Keystone inside. Just as the slide, the picture here shows, the modules contains all the functions that you need. And important thing is that this module already passed the tick mark. Tick mark is promoted by DRUK. It defines the minimum requirement of a receiver. The blue line you see here is the requirement, the minimum requirement of the sensitivity. In other words, signal as low as this blue line should be picked up. But you see the red line is the actual measurement of Keystone modules. In other words, even lower than the minimum requirement, the signal even is lower, but we can still pick up it. Then the difference between the two is called the margin. We give you a high margin. Okay, another thing is that to manufacture DAB receiver, test is very important. So affordable signal generator is essential for your success. We will recommend Sabre. Sabre is a unit I show in here, and now I will turn on my I will turn on my cam to let you see. Okay, the Sabre is very small. You can see it. I can hold it on my hand. And the modules are quite small. Just it is in my hand. Okay, so I will turn off my webcam now. Well, what happens to my?
Yeah, please click inside the slide and go next.
Is it okay now?
It's okay. If you want to go to next slide, please click inside the slide.
Yeah, but strangely, my slide does not. Oh, okay, it works again. Okay, this test equipment, just as I show you, I hold it on my hand. It is very competitive. It is only 17% of the usual instrument price, but it has many modes. It has a stand-alone modes, so that you can use it stand alone. You can use it in connection mode. It can be connected with a PC. If you connect it with a PC, then you can use the more richer figures to do the test. And it has network mode. What is network mode? Sometimes your testers work in factory, but your engineers are in an RD office. They are in different sites, but using the network mode, then engineers can help control the setting of the machine. And it has auto test mode. This is very important because the machine can do the test by itself. You don't need manpower to do it for you. I think another thing will be interesting to the government officials. That is to build up your local DAB manufacturing industry. So I think you will be interested in local supply chain and to produce cost-effective solutions so that you can provide the timely after service. Keystone is an affiliate of Prime Group. Prime is an IPO company in Taiwan, and we have a partner in Thailand, so we can help other partners to build up the factory in your local area. Okay, finally, the name of my company is called Keystone. What is Keystone? Keystone is the stone that you put on the building, the last stone that is put on the building. Therefore,
Yeah, excuse me, we don't see your slide. I think.
You don't see my slide?
Yeah.
Okay.
No, we see your slide is not moving. Please click inside the slide you have and go next.
Okay. Do you see it now?
No, we see only test is important slide.
Okay. So do you see my slide move?
It's not moving.
It's not moving? Well, how do I
No.
handle it?
Yeah, maybe. Do you have another screen? Okay, now, yeah, now
Computer
it's
working
okay.
now.
Yeah,
Oh,
now it's
okay.
okay. So we can see your DAB manufacturing industry slide.
Oh, okay.
Right.
Building local DAB manufacturing industry, right?
Yeah. Okay, go ahead. Okay,
Oh,
thank you.
okay. So this picture you can see it now, right? Okay, that's the one. Our name, the company name is Keystone. Keystone is the last stone that you put on the building. When the stone is put on the building, everything is finished. Therefore, put Keystone in your system. I think we already finished the last mile of the roadmap of the previous speaker. So hope we can be your reliable partner in DAB solution. Thank you very much.
Thank you, Albert, for that very interesting presentation on Keystone Technologies there. We see you have a very wide range of products and some very reputable products that you actually supply modules to. I'm just going to jump quickly to a question here that I did get, and it is, what is the blockage to stop DAB+ reception in mobile phones? And the answer to that is the telco. Because as Albert has demonstrated, the size of the solution for DAB receivers these days is very tiny, and it's also quite cheap, so it doesn't add a lot to certainly modern smartphone cost. So it's all about the telcos and the business case for telcos. It's not a technology problem whatsoever, and WorldDAB and others like the Omri Group continue to explore possibilities with smartphone manufacturers to try and move that forward. Okay, now we're going to move on to vehicles. In fact, connected vehicles. And I'll just bring my screen up here. And this is a presentation we're going to have from Roger Longto, who is the Director of Automotive Connected Mobility at Strategy Analytics. So this is a video, it runs about 20 or so minutes. So we are a little bit behind time already. So we'll move directly on to LP about Panetta head-in systems after this. Let me just start that video. And this should start now. So please enjoy. It's quite an interesting presentation about where we're going with vehicles.
Hello, this is Roger Lonto, Director of Automotive Connected Mobility at Strategy Analytics, working in the global automotive practice. Strategy Analytics is a market research consultancy. We've been looking at cars, automotive electronics, and connected cars for more than 25 years. And I'm here to talk about what's happening in the world of content consumption in the car. So we're going to look at the state of automotive connectivity, the battle over user experiences and interfaces in the car, a little bit of the impact of Google and Android, the emerging role of digital assistants, driver monitoring, audience measurement, car as a browser, and we're going to look actually at global in-vehicle listening research, actually, not just China. So I have some data just to share, and we're going to move through it fairly quickly, but I just wanted to give you an idea that this is the first year, 2020, when more than half of cars manufactured around the world will come with an embedded modem built in. So the car will come with connectivity built in. And that will increase to 72% of production by 2027. And this is to further give you a sense of the regional breakdown. And you can see the three most dominant regions are North America, Europe, and China. And this forecast is for gateway connectivity systems. So this is your Android Auto, your Apple CarPlay, your Baidu CarLife, what some people call smartphone mirroring systems in the car. So this has become quite popular. In a sense, it's either a supplement to the connectivity that's built in, or it's an alternative to the customer who wants to simply use the apps and content and streaming access that they have via their phone, and they just want to project it into the larger screen in the car. And it's important to bear in mind that one of the big changes that has occurred, that by now we almost take for granted, is that radio dial in the center console of the car is gone in most cars in most markets. Not all, but many. And it's been replaced by a larger screen that can accommodate these apps and this mirroring experience. At the same time, and a concept has been pioneered in Europe by Audi of hybrid radio. And this concept is actually being propagated by Volkswagen across all of its brands, so Audi, Porsche, VW, and others, which probably ultimately will include Seat and Skoda, across the world. So the idea that you're integrating together the terrestrial streaming broadcast source, the terrestrial source with the streaming source. So the broadcast terrestrial with the IP. The idea being that when you lose the terrestrial signal, this system will automatically pull in the IP stream content. Now that's also being enabled by other applications and other players, including actually the Android operating system is making provision for this, as is Google's Android Auto will be enabling the projected smartphone experience, will be enabling a kind of a hybrid radio experience. And so the companies contributing to this are Radio Line in France, Radio Player in the UK, although these are global applications, but I'm just talking about where the companies are located. Grace Note and Music Story are metadata providers. And so they're taking advantage both of the IP source and the digital and analog broadcast source. But the key difference is with a digital broadcast source, you're getting station ID, you're getting genre information, you're getting an artist experience, information about the track, information about perhaps the band, etc. So radio, in essence, is becoming a visual experience in the car, primarily in the car. And by the way, the significance of that is that radio listening in the car, and I'll get into this in a little bit more detail, but increasingly people are finding the radio in two places. They're finding it either via their digital assistant, like their Alexa device, or they're listening to radio in the car. In the US, more than 50% of radio listening occurs in the car. I'm told that that's higher than most other markets, but I have a feeling actually the US is probably pretty typical, that 50% of all radio listening occurring in the car is not unusual. Radio Line, I just have some more details here. So the platform brings together all that metadata. It operates in Android and other operating systems. It's a global platform, multilingual voice commands. So there's that digital assistant element that you can find your station via your voice. And it's bringing together broadcast and streaming sources. The same kind of idea for Radio Player, and both really are trying to create a personalized experience in the car. So it's not the radio dial anymore. It's going to be much more of a personalized experience, and increasingly we'll be taking into account content consumption behaviors to perhaps even make suggestions about other radio stations or other sources of content that the driver or owner of the vehicle or even passengers might want to check out. And then Grace, note again, radio as more of a visual experience, bringing together the music ID, station idea, maybe even sports or other kinds of event information, concerts and such in the car on the screen. So again, as I mentioned, digital assistants in the home, embedded radio in the car. These are becoming two very important content consumption hubs, focal points for the consumer. And this is just some data from some of our strategy analytics, other research outside the car, looking at how rapidly the digital assistant market is ramping up. And it's ramping up in a similar way in the car. You can see here the various digital assistant partnerships across the automotive supply chain and ecosystem. Increasingly, automakers want to be identified with Google Voice or with Amazon Alexa or whatever the regionally dominant digital assistant might be, in order to give that car user, that car owner, or even passengers better control over the experience in the vehicle. Meanwhile, at the same time, and this is a little bit technical, but I think it's important to understand, driver monitoring systems are being mandated throughout the world in order for car companies to achieve 5-star safety ratings. This is most notable in Europe with the Euro NCAP 5-star safety rating. We're just a year or two away from new cars getting new type approvals, having to have driver monitoring systems. Now that means, of course, these systems will mitigate driver distraction and try to prevent propositions like a drowsy driver or scenarios of this nature and other safety related applications. But at the same time, there will be an ability to identify the driver, to credential the driver, which will be useful for audience measurement purposes. Let me back up to the previous slide. Just so you know, there's a forecast in here for how rapidly these systems are going to be adopted. And then, so what I'm driving at is ultimately car companies will be working with organizations such as this, where the organization that this data came from. This came from Drive Time Metrics, where they extracted the content consumption data from the vehicle CAN bus. So what can be detected is artist, radio station, and of course that can be then correlated to location and time of day in order is a browser. Everything you do in your car is an indication of intent. And of course, radio is very closely correlated to advertising. Without advertising, there's no radio. Advertising pays for radio. But we don't know what people are listening to in their cars. Well, we are on the cusp of changing all that. We're at the early stages of developing resources for audience measurement in the car. That's important because we need to get these insights. We need to understand what people are doing in their cars. Are they listening to the radio? How much are they listening to the radio? Because what's happening in the car is you're getting an increasingly fragmented content consumption environment. And I'll have a little bit more on that in just a moment. And again, this is data from Drive Time Metrics from a panel that they were extracting data from. And you can see the kinds of insights: seeing, listening by hour of day, location, area, which vehicle models, critical information, which ultimately would lead to understanding consumer intent and attribution, which, correct me if I'm wrong, but I do believe attribution is the holy grail of advertising. If you can connect consumer behavior directly to advertising to which they've been exposed. So this idea of the car as a browser is an important one, and it helps to explain why Google is so interested in getting in the car. Currently, through smartphone mirroring of Android-based phones with Android Auto, but increasingly through the Android operating system. So this is a forecast of the Android operating system adoption. And you can see that blue bar at the bottom is increasing quite rapidly and displacing Microsoft, QNX, Linux in those infotainment systems that are in the dashboard. And those car companies that are identified here, these are all car companies that are either adopting the Android operating system or they're adopting the full gamut of what we call in the industry Google Automotive Services. So Places, Search, Voice, and of course, Google Maps. So the car is becoming a kind of a Google-fied environment, if you will, and increasingly suppliers to the automakers are finding ways to integrate radio, broadcast radio, with the Android operating system, with Android Auto, and with Google Automotive Services. And this is just some further detail about how these changes are happening and when. And you can see this experience today in the Polestar, which is available already in Europe. It hasn't yet come to the US, but again, the typical, what you're seeing in cars today, large screen and voice access to a wide array of functionality, and an experience that is almost identical to what you have on your mobile phone. That is the objective, to deliver that familiar experience in the car that is so natural on the phone. The good news in the world of Android is that radio increasingly will be available, not just as streaming, but via the FM chip in most Android phones. Sadly, Apple has not enabled the FM chip. So anyway, Android's playing, and Google is playing an important role. Just 3 years ago, Google and Android really had no provision for broadcast radio. That has changed, and digital radio is going to enrich that experience with that metadata that I was talking about, that visual experience of radio, to allow it essentially to compete. Now, at Strategy Analytics, we do a wide variety of consumer research. We do focus groups, we do customer clinics within vehicle systems, giving people tasks to perform and evaluating their ability to perform those tasks, both on a qualitative and a quantitative basis. So I have some data here from surveys of a total of 4,705 car owners across the US, UK, France, Germany, Italy, and China, asking them about their usage of AM/FM radio and other sources of content in the car. So when we ask people how often do you use each of the following features in your vehicle, you can see that at least 38% of car owners in Western markets use AM/FM radio in the car daily, with a further 33% using it once or twice weekly. Just 22% of car owners in China use AM/FM radio in the car daily. It's a very different environment in China. At least 27% of car owners in each market use streaming music services in the car daily. At least 24% of car owners in each market listen to owned music from a portable device in the car. From the standpoint of non-radio, so must-have features for the next vehicle, at least 53% of car owners in Western markets consider AM/FM radio to be a must-have, while only 46% of car owners in China feel the same way. Again, China's a little different. 51% of car owners in China consider streaming music to be a must-have, compared to just 32 to 34%. And 34 to 44% of car owners in all markets consider any smartphone mirroring system to be a must-have. That's a big headline takeaway. So mirroring of your smartphone for the average new car buyer is becoming a major priority, and that is a key entry point for streaming content. Now, I just have some additional slides here, and I believe these slides will be available to you. But you can see the change over time because we conduct the survey every year. You can see AM/FM radio is declining in the US. CD player, not surprisingly, is declining. We have satellite radio. That's kind of a unique scenario. Streaming is on the rise, CarPlay on the rise, Android Auto on the rise. The key here, though, over the top of this is fragmentation. So you're seeing a use of a wide range, and radio still is more than half as a must-have feature of respondents, but you're seeing a wider range of content sources. Similar scenario in Europe. Again, radio still more than half as a must-have, but streaming on the rise quite rapidly, actually, Apple CarPlay and Android Auto. And a similar scenario in China. So what is the takeaway from this survey? So 2020 is the year that the in-car AM/FM radio hit the proverbial iceberg. Two trends, one long-running, one new, have combined forces against in-car radio. Streaming media has continued its march into the dashboard, powered by strong usage and desirability among key car-buying groups in China and increasing usage among key groups in the West. The COVID-19 pandemic and its related lockdowns severely curtailed regular commuting journeys, and where much of this was a major impact in North America, and I'm quite confident the impact was similar in Europe, where you had lockdowns, people had nowhere to drive to, there were no events, no venues, no activities. This had a major impact on advertising, a major negative impact on broadcasters. This led to a marked decline in AM/FM usage and a steep decline in interest as a must-have feature. Some radio providers in the West are reporting that their ratings have tanked because many of those who listened on their commute have not rejoined from home. So working from home has become this massive phenomenon, and it may take another 9 to 12 months to sort all of this out and get back to some kind of normal. While radio still has unique advantages, the pandemic will only increase adoption of other media sources. The post-pandemic future of radio is even more uncertain, as Android Automotive and other systems embedding media apps will put additional pressure on radio, provided that these systems allow quick and easy login, direct access to streamed content without having to deal with Bluetooth or device cables, will result in further adoption and consumption. The key to keep in mind is that, yes, indeed, Android Auto and CarPlay are very popular. Android is increasingly providing for radio, as is the Android operating system that's being built into in-vehicle systems. CarPlay is not providing for broadcast radio other than streaming of radio broadcast signals over the IP. But for automakers, they are still committed to radio. And so it comes down to what the user experience is in the car. And that's why digital is so important, because it enables this visual experience in that larger screen in the vehicle, which is going to introduce something completely new and should, in some ways, reintroduce radio in a completely different way. Now, with regard to browsing and searching for content, new forms of discovery that will be enabled in this sort of IP-dominated space, there will be broadcasters that are a little bit uneasy about enabling a engagement proposition that allows for easy switching between sources. You know, why do I want to make it so easy to go away from my station? I think the key is to be everywhere, and this is one of the most important places to be. So we're not going to be pressing buttons to find stations or turning knobs. We are going to be requesting stations using digital assistants, and we are going to have a richer engagement experience. And in the not distant future, we'll be able to measure that experience. Now, 2020 is also proving to be a minor renaissance for smartphone mirroring systems after leveling off in 2019. Interest in these features as must-haves for the next car purchase has resumed the steady rise, as noted in the previous slides. Car owners continue to express a strong desire, not just for streaming media, but for advanced sat-nav functionality, as noted in recent report that we have produced, actually. And though they are still imperfect, CarPlay, Android Auto, and their relatives in China remain the best and most desirable way for drivers and passengers to access these connected services. So again, the good news is Android is providing for engagement with broadcast radio. In the coming years, media providers and product planners must resolve a number of long open tickets to address changing consumer habits in the car. Broadcast providers must double down on non-antenna strategies, podcasting that augment broadcast radio. Providers absolutely must know who their listeners are and what meaningful content sounds like to their listeners across delivery modes. So the measurement of this activity is going to be critical. This probably is going to call for a closer engagement with the automotive industry to work to obtain access to those data feeds that are available in vehicles. The data is there. and it's critical to access that data. Basically, the automakers need to be essentially educated about the value of this information and how it can be put to work for them to better understand their own customers. And the final slide here, as AM/FM radio continues its slow slide in usage and desirability, especially during the pandemic, and interest in streaming media continues to expand, designers and product planners must confront a number of issues. What are some new ways broadcasters can reach car owners during the pandemic? What are the unmet needs for CarPlay users or satellite radio users? Obviously, that's only North America. As level 4 semi-automated systems come online, which infotainment sources will become more desirable and which will fade away? Should cockpit screen design change to accommodate different needs for China or other regional markets with specific requirements? And these are the kinds of topics that we're evaluating. So I just want to double down on the point that the car is a browser. Radio is an advertising-driven media. We have the tools now to better measure audiences and content consumption in the car. Broadcasters need to steer in the direction of these trends, embrace these changes in order to take advantage of these new experiences in the car, and recognize and appreciate the fact that radio is becoming a visual experience. And while consumers can find your station with their digital assistant at home, only in the car will they truly have the opportunity to have that visual engagement with your content. Thank you for your time.
And that was the presentation from Roger Longtoe. Some very interesting comments in there about the directions that cars are going and how consumption will change. And it's up to broadcasters to make sure that the content they deliver keeps its currency and can certainly compete with those streaming services that he was talking about. But I think there's something we also almost must remember, and that is that broadcasters are now mainly content producers, and they do deliver streaming regularly. We heard from Joan Warner yesterday, who's saying that it's typical in many countries across the world that streaming is about around 10%, plus and minus here and there. So, and that streaming is for their content, not other sources. So it's a multi-delivery world. But the baseline is digital broadcasting, as Roger pointed out. Anyway, let's move on. It's now time to talk about encoding and multiplexing systems, and we're very fortunate to have Lars Petter Lundgren here from Panida. LP has been in the game for a very long time, haven't you, LP?
Yes,
and
correct.
is well respected around the world. So I'm going to hand over to you now, and let's hear all the latest from Panida. Thank you very much. Over to you, Lars.
Thank you very much, Les. My name is Lars Petter Lundgren, and as Les was saying, I've been around for a while. I've been working with DAB since 1997, actually. I'm working as marketing director for Panida. And Panida is a Norwegian company with its head office in Norway, but we also have a research and development office in Sweden. We are active in 3 different areas. In Norway, we have built and we own and operate the national DVB-T2 network with 165 TV transmitters. We have also provided over 200 DAB emergency break-in systems in Norwegian road tunnels. And we are also a leading supplier of DAB multiplexer systems. And to date, we have over 100 DAB systems on air worldwide. I'm going to talk about DAB head-end systems today, including DAB multiplexers, DAB encoders, and data insertions. The DAB system is typically realized in 3 different kind of setups. Normally, it's about realizing the system in a dedicated hardware platform, or realized on a server-based platform. And a DAB system can even be realized as a cloud service. What we have seen today is that 80% of all our customers prefers server-based approach for a number of reasons. The server approach offers a number of benefits. It's using virtualization with VMware as hypervisor enables you to install a number of systems, independent systems, on the very same server platform. We have customers running, for example, 10 multiplexers with more than 100 audio services, audio encoders on the very same physical server. So that's quite amazing. We can provide a complete system to be installed in any existing server infrastructure. So if you have a server platform, we can use that. But we can also provide a turnkey solution with everything pre-installed. Another great benefit with the server approach is that you can expand with additional systems. With just a few mouse clicks, you can start a new virtual machine and a new multiplexer system without any hardware investments. And the complete system is, of course, web-based. A cloud solution is about that we can install a complete system in a data center somewhere, not managed by the customer itself. Somewhere on internet in a data center, we can install the complete system. And the benefits are quite clear. It doesn't require any hardware, of course. No skills. You don't need to have any skills about maintaining server platforms, IP infrastructure. It's managed by someone else on internet. The principle is simply that we need a data center, of course, and we are Google fans. We love Google. So in a Google data center somewhere in the world, we install the DAB multiplexer and audio encoders. We need internet, of course, to feed the system with audio and metadata. And we use internet to provide a user interface. And each provider can have their own or will have their own user interface to manage their part of the system. It means that many providers or many radio groups can share one single platform where each provider can manage their part. We need internet on the output, of course, to connect the transmission network. To ensure the most robust connection between a cloud system and your transmission network, we have developed a product called Cloud Connector. It's basically a gateway between a cloud multiplexer and your transmission network, and it's built for internet usage. Simply, you connect internet to the device, and the device will initiate and establish a connection to that multiplexer wherever it is over internet. The multiplexer and this device will establish a connection, and the multiplexer will start streaming back the complete DAB stream back to the device. And on the output, it's providing the standardized protocol EDI, where you connect your transmission network. And you are on air. We try to make things quite uncomplicated. We see the complete system as a black box where you just feed the system with your audio and metadata. We try to make things zero complicated. As DAB is growing worldwide and has been growing a lot the last couple of years, it had also been raised new tough requirements for DAB head-end systems. And I would like to say a few words about which improvements that has been taking place the last couple of years. One part is this. It's called service multiplexing. It's DAB standard. It's based on the principle that each studio and provider has its own equipment, its own set of equipment, management system, encoders, and multiplexer, service multiplexing, which is a cascade multiplexing where each provider is doing service multiplexing and feeding an ensemble multiplexer, and then it's multiplexed again. This is the yesterday approach. This approach has a number of disadvantages. The fact that you are doing a cascade multiplexing, it also adds a lot of latency. And it's also a rather complex setup where you need to deal with different interfaces for controlling and sending data and management, etc. And the communication protocol between the systems was never really adopted as a common protocol across vendors. It means that each vendor implemented their own proprietary protocol, and therefore it's not possible to mix different brands in this approach. We are instead nowadays focusing on what we call virtual providers. It's a more modern and simplified setup where you are sharing the same multiplexer platform. So you'd only perform multiplexing once. And you can also, of course, centralize the encoding and everything. The virtual provider concept is basically that we split the multiplexer in capacity slots and grant capacity units to each provider in the system, where they can use totally independent from the others the complete capacity range. So they manage and operate their part of the multiplexer. This is the most modern approach. This is how a system could look like. Instead of having multiplexers and everything at the providers, they can focus on the audio encoding only. So the studios can perform the DAB plus encoding at the studio and feeding the centralized system with audio. And you can also combine it with local encoders or centralized encoders, for example, to be used as a fallback, where if you lose connectivity between the providers and the centralized system, you can have a local encoder at the multiplexer that fall back to, for example, a web stream. And also by using internet, each provider will have access to the web interface so they can monitoring and operating their capacity range, and also to insert metadata, text and pictures and more. This approach has kind of almost no latency at all. It's very low latency and it's very less complex. It's a straightforward setup, and centralized means less equipment, and less equipment means less maintenance, of course. Another area I would like to talk about is redundancy. This is a traditional 1+1 setup where you have normally two multiplexers, one main multiplexer and one redundant multiplexer. And on top of that, connected to the outputs, you have a seamless switch, changeover switch that can choose the best possible input. This traditional setup has a number of disadvantages. For example, if one service fails, if only one service fails in the main system, that changeover switch will detect that and change over to the redundant system. In fact, forcing everyone, every provider, every radio service will be forced over to the redundant system, even if there is only one that has the issues. And each of those switching is actually potential audio glitch. But worst is that it's not fault tolerant against multiple errors. So in the case where you have different audio failures in the systems, for example, when audio 1 has failed in the main system and audio 2 has failed in the redundant system, that seamless changeover switch has no choice. it has to choose either A or B, with the resulting silence on air for a service. We have developed a workaround. We call that the Panida Content Aware Smart Switching, and it's about that we have a content aware switch installed before the outputs in respectively multiplexer, and that switch are content aware, and the content aware switch can combine individual services from either systems and compose an error-free output. So in this scenario where audio 2 has failed in the main system and audio 1 has failed in the redundant system, these two smart switches will pick services, individual subchannels from each other, and both are able to compose an error-free output. And this has been very, very appreciated in the industry the last couple of years. Another area where improvements has been taking place is the audio handling. Nowadays, a modern DAB system is much more service oriented. You create a service, you point that to an audio source, and the audio source is a logical audio source. And under the hood, that audio source points to physical audio inputs. Your main audio, which can be AES EBU, it can be AES67 or any other IP format, for example. And you also specify a redundant audio source, audio input for that audio source, which can be, for example, a web stream. You can even specify playing an audio file as worst case. And best part is that all these inputs you specify, they are hot and live and monitored, means that we will never change over to a non-working audio input. So they are active in the system, even if they're not currently used, they are active and monitored. A modern DAB system must today fulfill a number of tough requirements regarding IT security. For example, the connections must be encrypted where applicable. We need a secure database. No more storing usernames and passwords in clear text. We need to have an encrypted user database. We need to support two-factor authentication for the highest level of security. We need to make sure that the web interface is secured by HTTPS, or also called SSL, and using valid certificates. The users must also be defined with a clear user right and different roles in the system. And we are proud to say that our system is A+ ranked, the highest IT security grade. A clear trend today is to centralize even more. And what we're talking about is to also move audio encoders to one single place, to a centralized multiplexer center where you perform multiplexing, audio encoding, data insertion, everything, and let the providers, the radio station, feeding audio into the system instead. And the benefit is that it's an even more simplified setup, and we let the providers focus on their content, or they can focus on their content. And it's a more efficient setup where we can use normal and standardized IP infrastructures. For feeding audio into the system, you can, for example, use an audio contribution system. Just to mention one system from the company 2W.com, they have a solution where we installed just a simple IP encoder at the studio and contributing the audio into a centralized audio server. And this audio server is normally installed as part of the complete DAB system on the very same platform. And each provider can choose their own codec or any codec that they prefer between the studio and the centralized audio server. And the audio server can handle a large number of studios. The audio server will always output linear audio in PCM format to the head-end system, the multiplexer system. So PCM is the only format that the multiplexer system needs to deal with. There are a number of benefits of doing this. It's about that we have separated the audio part from the DAB part, basically. Means that at any point, we can replace the multiplexer system with something else, because PCM is quite standardized, so every vendor can handle PCM audio. And it's also a generic audio approach. It will be less maintenance in the future, where we don't have to upgrade the DAB plus encoders every time we upgrade the multiplexer system. So there are a number of clear benefits of this approach. Another thing is about synchronizing the outputs from the DAB systems. EDI is a standardized protocol for the output of a DAB multiplexer, and the synchronization of EDI, or to start with, EDI is structured in what's called PFT, small fragments of data. And the first thing is that these fragments must be synchronized, means that the same fragment number must contain the same data. The disadvantage is that if you have a packet loss that hits the network at the same time on both feeds, as you realize, the same data will be affected at the same time, and that it will be an outage, it will be a data loss. The workaround for that is called time shifting. Basically, you are delaying the second EDI output slightly, typically 50 milliseconds. The PFT fragments is still synchronized, means that the same fragment on both streams contains the same data, but they are not present on the network at the same time because they are time shifted. And by doing that, the same packet loss on your IP network will not affect the same data at the same time. And if you have a PFT-aware EDI changeover switch or a converter or even a transmitter that are PFT-aware, that unit can cherry-picking PFT fragments from either stream without any impacts on the output signal. So that's a nice feature. Today, we are using more and more web interface, and we implement local language for every market we have sold equipment to. So we are supporting a large number of language today in the web interface. Again, we try to make it zero complicated. A few words about warning system. We have developed a new concept called Panida warning system using DAB as a trigger and carrier of a trigger message. It's meant to be a machine-to-machine, means that the trigger message will trigger something. Let me say a few words about that. First, DAB, as you know, stands for digital audio broadcasting. It's true, audio, yes, but it's basically also a digital carrier of any data and can carry any data. Simplified view of the DAB signal, it's divided into audio data and some headers and signaling. The FIC channel, fast information channel, carries a lot of labels and program information, etc. A part of that FIC channel is unused or reserved for future use, and that's where we have implemented the Panida warning system signaling. a trigger signaling system. For the purpose, we have also developed a number of receivers. It's basically DAB receivers listening for that trigger signal. And the receivers are meant to be outdoor installed, so they are IP67 classed. And we have developed a number of different receivers for different purposes. For example, we have developed a unit where you can connect sirens and loudspeaker systems. We have another version where you can control different relay outputs for mechanical things like road blocking systems. We even developed a version with HDMI where you can hijack a dedicated screen or an existing screen. So you just connect this receiver to any screen using HDMI. For example, a screen normally showing train information. But if an incident occurs, we can take over that screen and instead showing a graphical message or playing an audio or whatever it is. The signaling system, the trigger system we have developed is addressable. It means that we can address a single receiver, a group of receivers in an area, or maybe all receivers. Last year we did a demonstration of an application where we were using this signaling system for an air quality system. We did a demonstration where we had a couple of connected screens, dedicated screens, showing an air quality index. And we were also measuring in real time from the international database of air quality index. And we specified a threshold value. And when that threshold value was reached, that automatically triggered a message to be sent out to those receivers in that area. The graphical message can contain detailed information. You can also triggering an audio to be played out, for example. So this is one example of an application that can be used for this, not only emergency. Another is scenario that describes what you can do with this system is for terror attacks. Imagine that an operator triggers a scenario called terror in an area called Karl Johan, and Karl Johan is the city center in Oslo, the capital city in Norway. Immediately when the operator triggers the scenario by pushing a button or whatever it is, it will be sent out across the DAB network in the country. The trigger message contains the type of message, which area is affected, and what actions these receivers shall do. An example, the dots you see indicates where we have receivers installed, and the first thing that could happen is that starting loudspeaker systems in that area, emergency seek shelter message, for example, and also taking over screens in shopping malls or advertising screens, outdoor screens, etc. And at the very same time, we can activate road blocking systems in the surrounding area to prevent further traffic into that area, or even playing another audio message for public nearby that they shouldn't go into that direction. On the highways and the surrounding highways, we can close the gates at the road tolls, for example, to prevent traffic into the city, and also inform these drivers by connected screens. So that's another example. The key benefits of using DAB for emergency and warning systems and other applications is that, of course, we are using an existing infrastructure. Once you have built your DAB network, we can use this for other things. And DAB is probably the most robust broadcast system we are aware of today. It's built for the highest uptime ever. And it's very efficient. When you trigger the emergency message, we can trigger all devices nationwide within 1 second. And my favorite, have in mind, we reach people not listening to radio. Radio still has an important role to inform the public when a critical incident occurs. But here, we reach people not listening to radio or having their mobile phone on hand by connected screen, loudspeaker systems, and other things. And what we can do is connect light, sound, loudspeakers, kind of almost what we want. If you have time, I recommend you to visit our website. Under panida.no, under references, you will find a YouTube clip showing a live field test we did in a city in Norway. We did a live test with evacuating a city using our systems with loudspeakers and sirens and screens, etc. So please have a look. And that's all for me. Thank you for listening.
Thank you very much, LP. I'm particularly pleased to see the use of DAB for other data services. I spoke about that yesterday, and I think that's an excellent application you have there, and a lot of additional capabilities and applications come to mind. Maybe we'll have a chat sometime about that. So,
yeah.
So when we can get together, maybe. So anyway, we're just about out of time, but we get another presentation yet, probably one of the most important of the day, and that is from Ms. Razri Srirasa, who's the Director of Satellite and Orbit Management Bureau at the MBTC in Thailand, and formerly critically involved with DAB in Thailand. So without any further ado, please stay tuned to hear Razri's presentation. Over to you all. Thanks.
Did you see my screen?
Not it. Please share your screen. Yeah, please go full screen now. Yep. Right. Thank you. Go ahead.
Yeah, thank you, Alex, and thank you, WorldDAB and ABU for giving me an opportunity to sharing experience on the trial in Thailand. First of all, I would like to introduce my organization. NBTC is a national regulator responsible for frequency assignment, telecom broadcasting, and satellite licensing and regulation in Thailand. And finally, I would like to brief the background on the digital radio in Thailand. As a national policy levels, we have a national plan called Thailand Economy and Society Development, and also a broadcast master plan. This plan mandates that Thailand have to transit to digital broadcasting, including digital radio, and we have to provide the service covered nationwide. So we set up many projects relevant to digital radio. In 2014, we have joint project with the ITU and NBTC to develop the roadmap and strategy to deploy digital radio service in Thailand. And also we conducted a series of projects, for example, frequency planning, user survey, economic and social impact on digital radio deployment. And in in September this year, we also finished 2 projects. The first project is the trial in Bangkok, and another project is Sadia radio broadcasting trend. And we developed the guideline for the future regulation to conform with the technology and user behavior change. And regarding to the ITU and NBTC joint project, we study technology choice, and You may heard that in Thailand already complete the analog TV switch off in March this year. So we have a VHF band 3 available for digital radio. And we did the assessment of four technology system. And we found that only the Plus is a realistic option for Thailand as an ITU consultant recommend. And after that, we developed the NBTC notifications. We just published the notification on the frequency plan for digital radio trial. This plan is define the system and technical data for trials. Sorry. And we have the frequency for 10 major cities. And we start trial in Bangkok. And we plan to expand the trial to the regional area in 5 areas. In the north, in the south, and in the east, also in the central areas. And for trial in Bangkok and vicinity, we use the frequency block 6363, frequency from 185 megahertz at the center frequency. And going to the project digital radio trial in Bangkok, we have started from 2018 to 2020. And in this project, we have the MOU with the Royal Thai Army. The scope of this project is to do the technical test to find the proper parameter in each environment condition in building, in car, outdoors. And also in this project is also provide a radio receiver. It's approximately 3,000 models, 3,000 units, consists of 5 models: table radio, hybrid radio, radio in car, and also portable radios. And we aim to test the service, the basic service, and also the advanced service, audio service, and the new service such as the traffic service, the hybrid service, pop-up service. And besides this, we have developed the business plan together with the broadcaster, and we have the capacity building. We organize workshop with the cooperation with the international organization like ABU and also WorldDAB. And for coverage, we did the coverage prediction by simulation many models. We vary the frequency and vary the antenna direction. At first, we set the transmitter power to 2.3 kilowatt, and then we did a dry test and we expand to 10 kilowatts. For the antenna system, we did the simulation from 0. We have 4 models, and finally we tune the parameter and the coverage that we select to change the antenna. We decide to change the antenna to 135 degrees. That can provide the coverage more than the other option. So in the trial, the coverage can cover mobile reception, can cover population more than 10.4 million, and also for portable reception can cover the coverage more than 9.5 million populations. And now for that trials, we use the existing transmitter, which is located at the Royal Thai Army Radio Communication Department. And we equip the antenna. We use a Thai antenna and equip the head end at the transmitter side. And this trial system can equip only one multiplex, can support 19 service. And for we also have the software to monitor and control the service and configurations. And during trial, because we would like to engage the broadcaster, so we invite the 13 incumbent broadcaster. This broadcaster consists of the commercial and public services, and also major radio broadcaster in Thailand. For example, is FM 95 is a ranking #1 of radio station in Thailand. Cool Fahrenheit is the ranking #1 in pop-up music. Just 100, the most famous traffic report radio station in Thailand. And here is the service that we can monitor from the observer. So you can see the service and the logo available and the bit rate, the radio mode. And it also can support, can display a Thai language. For Thai outfit or video, after we set up and equip the transmitter site, and we plan to divide the service into 3 phases. The first phase is the aim is to test technical. We do the signal measurement test and basic service. And the second phase, we did the basic service and prepare to test the advanced service. And for phase 3, we test the advanced service like hybrid radio and traffic service or announcement service. So here is the example of the service test for the service test. This is the text scoring and slideshow. We did as we cooperate with the broadcaster. So we let them send the image or the text, and then they can change. They can select the slide or the text that they would like to display on the receiver screen. For the feature test, during a technical test and a basic test, we have 2 important tests, feature test and a field test. For feature test, we try to test all feature that we heard that digital radio have this feature. So we begin with the audio service test. We vary the bitrate from 32 to 128 to verify that if we increase the bitrate, the quality should be better. And we also test the text scoring and slideshow, as I mentioned earlier. So this service is work well. For service linking, handover between DAB Plus and FM. This service, we have to set the parameter at the DAB system service ID at that system, and also we have to set the PI code at the FM system to match together. This service linking is work when we change when we move from the DAB Plus coverage to FM coverage. Is an automatic switch to the FM system, and also the service is also the service DAB Plus service is automatic switch to FM service, and vice versa. For traffic, we have the cooperation with with the assistant from Dr. Les. We have the cooperation with the Germany company, and we have the simulate the traffic service or TPEC test, so we can see the traffic status, the traffic warning, and also the traveling information. So we demonstrate this feature to broadcaster, and the radio broadcaster will provide the traffic report. Just 100 that they are interested in this service. For hybrid radio, we cooperate with the radio DNS, and we test the radio's hybrid between DAB Plus and online on the mobile screen, LG screen, to demonstrate this feature is work. And for the announcement or emergency warning, This feature is also work well in Thailand as well. We can play the announcement tone or can switch to another radio station that's broadcast announcement message. And for pop-up service, because we think that in Thailand, we may set up the temporary service or temporary station. So we set up the NBTC test channel to test a pop-up service. For field test, we did the field test, and dry test and stationary test. For dry test, we did the dry test on the tollway, the main road, and also the business area. And the outer ring, that's a boundary of the cover, but the boundary of the coverage. And now we collect the result from a 12 dry route, and we found that some area have the lower signal, or some area we found the other homes. So we also found that there are many high-rise buildings in Bangkok and in this area. So we tuned the model, the simulation models later on. And for the field test stationary, we cooperate with the broadcaster and we let them propose the test location. So we did the stationary test more than 50 locations. And key finding from the stationary test, we found that the signal is lost about 10 dB from outdoor to indoor because of the building wall, because of the mirror, the mirror frame. And also open and close the door or window is also impact to the signal coverage significantly. Besides this, we found that the electronic device like a computer in the stereo station also impact the signal qualities. And after we did the project in the final phase, we did the survey on 2,000 users that received the digital receiver provided by NBTC and Royal Thai Army. We did 3 times of survey, and we found that they often use or listen to the radio in car and home, and the favorite content is news and song. But we still found the signal unstable in some area when they are in the high-rise building and at the coverage boundaries. And the feedback from the user and the broadcaster is they would like to see variety of content. So we should have the software to manage the content delivery of it, to create a dynamic content. And in the whole area, they recommend to add more sites or recommend us to add more service to support more channels, more multiplex to support more service. And besides this, we try to, because we have the consultant in Thailand, we have a consultant in engineering consultant, strategic and communications consultant, and we also have less in effort in a digital radio consultant. So for communication, we organize the digital radio local contest. This is the digital radio contest that we use this logo, and we ask the broadcaster to broadcast this logo for communicate. And besides this, to achieve the objective of trial, NBTC set up the working group and regular meeting every month for the digital radio trial in order to deploy the digital radio service in time and have good understanding and cooperate among the stakeholder, broadcaster, car manufacturer, and also communication agencies. And Last slide is the lesson learned that we found from the trials. For coverage, we think that we need to do, or we have to do the right test to fine-tune the coverage model. And after we fine-tune that, we can see that we can improve the coverage later on when we did the right test, and we know that which area should expand the coverage or which site should be add more. And moreover, the service should expand to the regional areas. And secondly, for field tests, after field tests, we can adjust the power and antenna direction. And we can find, as I mentioned, that we can find the problematic areas. So we recommend that we have to do the regular field test when we change the parameter, or when we change the condition or setting at the transmitter side. And next is the connection between transmitter and studio. Because of limited of the budget in this project, so the link between the studio and transmitter side is IP link. So sometimes the service is unstable. So we recommend to use a VPN or dedicated link, and also equip encoder at the studio side to improve the voice to audio quality or service qualities. And for the service channel in this project, because we would like to invite a number of broadcasters, so we can allocate only 46 kilobits per second per service. But some broadcasters, they would like to test more, to provide more service. So we may provide or allocate more than 64 kilobits per second for some broadcasters. If they offer if they propose the proposal that they would like to test a digital system or more than a digital service, more than an audio service. And for the software, broadcaster, because they don't have the software to manage the service, so the content is not dynamic enough. So we think that we should support a rapid software for the new project or the new expansion to manage the metadata. And for announcement service, we found that this service is very interesting. So we think that if the public radio apply this service to warning air pollution or flooding in Thailand, it would be better. And for the traffic TPEC, we found that in Thailand, they have many traffic radio stations, some of traffic radio stations. But we don't have the central traffic database. The police traffic radio, they have some traffic information. So we think that it should have the cooperation between traffic management agency in Thailand and with the radio station to set up the central traffic database. If Thailand would like to provide the TPEC service. And the important thing is the collaboration. We would like to engage more broadcaster and car manufacturer to enroll in trials. And lastly is the receiver. In this project, we have the receiver that support Thai language, but we would like to have more models, variety model to support Thai language. So this is the lesson learned from the trials that we have learned. And we think that we should improve and maybe a benefit to others. Thank you. This is an presentation. Yes.
Thank you very much, Leslie, for that excellent demonstration of how to establish DAB and trials. I think the Thailand experience was really a very good one. It was very thorough. and it's now moving to the next stage of expansion, and hopefully we'll be able to hear about more of that another time. But all very positive news. So at this point, I would like to thank everybody. We had some very useful information from Kath about how to establish the market, and I think that was well supported by Orn's presentation, which covered all of the main topics that Kath was talking about. So that's just a great demonstration. We had very interesting information from Albert about receivers and new products that were coming online there. We had some revelations, you might even call it, predictions from Robert Langto about connected cars, and we'll see how they pan out. And we had some really interesting new concepts in multiplexing systems and how they're evolving, and new data services from LP Lungren. So overall, I think we get some good coverage today, and I thank all our speakers for their time, and I thank all of our attendees for their time. Thank you for attending. Please get any further questions can be sent directly to myself if needed, on my usual email address, which I'll just put up here. That's sable@escomtech.com.au. If you have any further questions, we can answer tomorrow. So I'd just like to close at this point, because we are almost half an hour over time, with what's on for tomorrow. And tomorrow is all about transmission and RF planning. So we'll go through transmission system overviews, what a modern transmitter consists of. We'll look at coverage and interference planning, and we'll finish off with a discussion about the new WorldDAB Asia Pacific Technical Group, and what that will do and how you can get involved. WorldDAB is always very interested in helping all stakeholders in the DAB world. So any questions, anytime. So with that, it's just coming out to 5. I was just trying to get on the mark. I thank everybody again, and have a great day. Thank you all very much.
Thank you.
Bye.
Thank you very much. Bye-bye.
Bye-bye.
Okay, thank you very much, Les, for your great moderation, and all the speakers for their excellent presentations. Of course, we have come to the end of day 2, and we have one more session tomorrow. Please join us tomorrow if you feel your friends, colleagues would benefit. So please share the link. Okay, but with that, we have come to the end, and thank you for your participation, and see you tomorrow. So with that, let me close the webinar for today. Okay, thank you, Lish, and thank you all speakers for today's presentation. Okay, see you tomorrow. Bye. Have a great day. Have a great day.
Bye-bye.